Hello everyone, we are going to present our thesis paper entitled Development of Root Zone Cooling RZC System for Simple Nutrient Addition Program SNAP Hydroponics of Spinach. This paper is presented by Kenneth OSAKO, which is me speaking, and my thesis partner, Eden Veronica S. VILLAR. So for the introduction, the quality of growing plant crops depends on a variety of factors like ambient environment temperature, humidity, fertilizer content, water intake, air, and light exposure. So it means that the growing vigorous plant crops depends on this kind of factors. So to be able to produce a significant um, crop output in the long run. So in terms of crop quality, to be able to produce a crop yield or a profitable crop yield in the long run, so these kinds of crops must be exposed to a proper abundance of sunlight, water, and proper soil nutrients. So according to a study conducted by Sardare and Admani on their paper, they states that growing plant crops under indoor farming methods such as growing crops without soil or the so-called soilless culture on their paper improves crop yield and quality. So, study another paper conducted by Ilahi, Ahmad, and Hussein argues that RZC or the root zone cooling technique alleviates any damage to crops that are caused by high temperature. So, they also argued that the resulted crop yields are improved growth and development of these crops. Since the effect of RZZ is attributed to photosynthesis, assimilation of partitioning of the plant, and absorption of water and nutrients by the plant. So RZZ is just a feature of the SNAP hydroponics. And SNAP hydroponics is just a subset of hydroponics. So the general term here is hydroponics. So a SNAP hydroponic setup requires a planting container that can hold for about 2 liters of hydroponic solution and planting pots to hold those vegetable crops that we are going to be using. So the state of the problem for our thesis study is a lack of study about root zone cooling optimization using SNAP hydroponics being conducted in the Philippines. So right now, there are about a few research that are being conducted that relates only to SNAP hydroponics. So there is a need to for more research to be done regarding this subject matter. So the need for the study. So what is the need for the study? So there is a need to know about the effects of applying RZC in the cultivation of crops in a tropical country like the Philippines, so which is one of our objectives also. So what are the objectives of the study? So the general objectives of the study is to know the effects of RZC in a SNAP hydroponic setup. So that's our general or main objective. So the specific objectives of the study are to develop 3 different SNAP hydroponic setups in which one of them will not be applied by RCC and 2 of them will be applied by that technique. So next is to calibrate the functionalities and sensors of the system, and finally to use statistical approach in determining whether root zone cooling significantly affects the cultivation of spinach or if it has a significant byproduct result in the end of this experiment. So what are our scopes and delimitations? So the study will only focus on the effects of root zone cooling optimization and not go beyond this kind of indoor farming method. So in SNAP hydroponic setup to spinach crops planted in lowland areas. So we are only going to focus our time on spinach crops. So the 2 setups that will be controlled at a temperature of 25 degrees Celsius for setup 2 and 20 degrees Celsius for setup 3. And data gathering are to be conducted for 30 days. So data parameters such as number of leaves, plant height, and leaf area will be measured every 5 days. So for our methodology, here's the block diagram of the SNAP hydroponic setups that we are going to be using for our control system, which we are going to present later. So as for the brain of the system, here's the microcontroller, which is an Arduino board. So it is powered by a 5 volts power supply. And as for the inputs to that microcontroller, here's a water temperature sensor, which is going to measure the water temperature of the planting container. So as for the outputs, there are 3. So pelter module, water pump, and LCD display. So for pelter module and water pump, we need to bias those to work efficiently. So we need a 12 volts power supply so that um, they will work the way they should be. So the next figure is the isometric 3D model of the prototype. So here is the whole view of the prototype. So it's an isometric 3D model. So the huge box here is the planting container that we'll be using. It's a plastic container. So above that are the spinach crops suspended on a plastic cup containers that are floating on a snap hydroponic setup solution below that. Okay, so here are the dimensions for that container: 14 by 16 by 30, And as you can see on the right hand side here, that box container over there is is it houses the prototype circuit that controls, or um, that used to be the brain of the prototype. So it houses the Arduino board and other electronic components inside. So it measures by 6.5 by 2.5 by 4.5 inches. So as for our conceptual framework, so input, process, output. For our input, there are two. So water temperature data from setup 1 to 3 and air temperature from data from setup 1. Process, control water temperature to 25 degrees Celsius for setup 2 and 20 for setup 3. Also, record high and low air and water temperature from setup 1. As for our outputs, display water temperature in LED from setup 2 to setup 3, turn and off the water pump and pelter module, and display high and low air and water temperature from setup 1. As for our methodology, this is the system flowchart for setup 1. First, we initialize the system parameters. So we are going to record all of our parameters to 0. So acquire water temperature value, acquire air ambient temperature. If high water temp is less than acquired water temp, high water temp is equals to acquired water temp. So it's actually self-explanatory, so I'm not going to tackle that about. So, but the logic here follows the first diamond decision box here in the above. So, um, it's the same for those decision box below. System flowchart for setup 2. We initialize the system by turning on the water pump initially on the start of the testing for setup 2. So setup 2 is the container again that is maintained at 25 degrees Celsius. The first input to this flowchart is to acquire water temperature value in that plastic container. If temperature is less than or equal to 24.5, we turn off the pelter module and output cooling off. If that's not the case, if the temperature is greater than 24.5, we go into this diamond decision box next. Temperature is greater than or equal to 25.5. So if that's the case, then turn on the pelter module and output cooling on. And if that is less than 25.5, then you simply end the flowchart. The same as goes for this next system flowchart for setup 3. The difference here is we just change the temperature values. The temperature value ranges 19.5 and 20.5. Our list of materials include Arduino Uno, waterproof, digital thermometer water sensor, 12 volts water pump, I2C LCD module, pelter module, DC to DC buck converter, and 12 volt power supply. The control system maintains the cold temperature using an Arduino microcontroller. So, using Arduino microcontroller, um, it mani it what do you call this? It it utilizes the control system. The input for the system is just the water temperature sensor for setup 2 and 3, and included the air temperature sensor for setup 1. As for our experimental setup, there are 3 hydroponic setups in place. 2 of them will be implemented using RCC technology. 6 spinach crops will be planted. So 4 crops will only be used for data gathering part. The 2 are only used for reserves. Plastic cups will be used as the pot for the crops with 50% cocoa and 50% soil medium inside. What are the parameters that we are going to measure? There are 3. Number of leaves, plant height, and leaf area. They will be measured every 5 days, and here are the procedures on how to measure each one of them. Each one of them will be measured on a frequency of 5 days. Our statistical treatment states that our null hypothesis states that there is no significant difference in growth between spinach grown under the system with RZC and system with ambient root zone temperature. The opposite goes for alternative hypothesis. So this means that we must we must reject the null hypothesis in order for our study to conclude that growing plants using RCC has an increase has a significant increase on the growth on the growth parameters that I discussed before, the 3 parameters, with respect to a setup that wasn't applied by RCC, which is in this case setup 1. Here are our mathematical equations. So equation 3 is used to get the sample means, and equation 4 is to compute the t-statistic value. Analysis of results. So first picture is for setup 1. second picture, setup 2, and third picture, setup 3. As you can see, the biggest or the most improved effect of using RCC is on setup 3. Here is the average increase in the number of leaves. Here is the data. This is just the difference of the recorded data. So it is measured. Okay, this is for the plant height. This is the leaf area. Um, it's measured using these equations, the values here. Okay, next, percentage table of the increasing growth for both setup 2 and 3. Here are the percentage increase for the growth of leaves, plant height, and area under setup 2 and under setup 3. As you can observe, um, growth percentages are highest on setup 3, which means that we have a very significant increase on these three parameters here under 20 degrees Celsius, which is used to be maintained on setup 3, compared to setup 2 under 25 degrees Celsius, which means if the setup is cooled at a lower temperature, like 20 degrees versus 25 degrees for setup 2, 20 degrees for setup 3, um, under 20 degrees, we see the optimum effect of using RCC. So to compute this, we just use this equation. So, so, so here are the test statistics based on the number of leaves for all plants in setup 1 to 3. For setup 1 to 2, we compared the two. Setup 1 to 3, we compared again the two. Both of them, we reject the null hypothesis. This just means that comparing setup 2, setup 3 to setup 1, their setup 2 and setup 3, both, since they have rejected the null hypothesis, both have significant increase on those three parameters compared to setup 1. Okay, we just use 95% confidence interval, degree of freedom of 5. So this is just all what it says. Okay, the same goes here for plant height, also here for leaf area. But notice here, we fail to reject our hypothesis on setup 1, setup 2, which means here, based on the leaf area, that setup 1 is most productive than setup 2. But this is just a effect of, this is just a result by chance. Since most of the data here have rejected the null hypothesis, we can successfully conclude that snap hydroponics applied with RCC was proven effective with an increase in the number of their leaves, plant height, and leaf area. Under 25 degrees, here are the values. Under 20 degrees, these are the highest values obtained, the highest percentage values. That concludes that at 20 degrees Celsius, RCC was optimum at this temperature. Okay, it was found out that increasing root zone level to less than this and more than 25.5 degrees Celsius has the effect of reducing the effectiveness of RCC. So our recommendation is to be able to acquire the cold temperature to the RCC setup. We can try insulating foil covers that are to be attached on planting containers to be able to trap the heat inside effectively, or by using better heatsink and thermoelectric paste to improve the efficiency of thermoelectric cooling so that we can cool the system faster because it's kind of slow. Okay, before I would conclude this presentation, I would just like to acknowledge our thesis advisor, Engineer Mayor Vincent Caya, for guiding us, our thesis panels, our friends, family, and also to the Almighty God. So thank you for listening to our presentation, and thank you.